You know those massive ships that carry literally everything? Your phone, your food, your car? Well, they're going green. But this huge clean fuel revolution has a secret, kinda dangerous side. So today, we're going to dive into the invisible rulebook that's being written right now to keep all of global trade moving, and moving safely.
So here's the big question facing the entire maritime industry, right? How do you power 90% of global trade without, boiling the planet? For decades, the answer was, well, it was cheap and easy, but it came with a massive environmental price tag. Now, the shipping world is making a huge bet on a cleaner future, but it's a future that's packed with new and really complex dangers. Yeah, this slide really breaks it down perfectly. On one side, you've got the old stuff, heavy fuel oil. Sure, it's disgusting, super polluting, but it's simple. We know how to handle it, we know the risks inside and out. But on the flip side, you have the new kids on the block. Fuels like LNG, ammonia, and hydrogen. They're amazing for the climate, but they are incredibly complex and hazardous. We're talking about stuff that's cryogenic, so cold it'll burn you, toxic, or way more flammable than anything we've dealt with on this scale before. Okay, so how on earth is the world's most essential industry going to manage this incredibly risky change? Well, here's our game plan for this explainer. First, we're going to pull back the curtain on the global safety rulebook that's making this all possible. Then, we'll see how those rules get physically built into the ships of tomorrow. After that, we'll get into the weeds on the unique dangers of ammonia and hydrogen. And finally, we'll talk about the most important part, the people and the tech that have to make it all work.
So how do you get every single country, every shipyard, and every shipping company on the exact same page when it comes to safety? Well, you've got to create a single, mandatory, global standard that everyone has to follow. And in the world of shipping, that standard has a name, the IGF Code.
Think of the IGF Code as the master rulebook for this whole new era. It's actually part of a much bigger international treaty called SOLAS, which is basically the Constitution for Safety at Sea. The IGF Code is the specific chapter that lays out all the nitty-gritty, mandatory rules for building and running a ship that uses these new, more volatile fuels.
Right, so these rules don't just magically appear. They're forged through this really careful, years-long process at the International Maritime Organization. It all starts with the experts spotting a new risk. Then, they draft the technical solutions, which get debated and tweaked. Once everyone agrees, the rules are formally adopted. And finally, a date is set, and bam! That rule becomes law for every new ship built anywhere in the world.
Okay, so that's the theory. That's the high-level process. But what does this actually look like on a real ship? I mean, how does a line of text in some rulebook in London actually translate into steel and safety systems on the high seas? Let's look at some really cool examples.
All right, check this out. It looks like a simple bit of algebra, right? N-1. But this little formula, it's a huge deal. It's one of the most important new safety principles in all of shipping. For a vessel carrying thousands of tons of super-chilled gas, this simple idea is an absolute game changer. Any idea what it's for?
It all comes down to one word, redundancy. See, in the past, you could just add up the capacity of all your pressure relief valves to meet the safety requirement, but a new rule coming in 2026 says your system has to be able to handle a worst-case scenario even if one of those valves is completely out of commission. That's the N1 principle. It's a safety net to make absolutely sure a tank can't rupture from too much pressure. Okay, here's another one for you. 300 millimeters. It's tiny, right? It's about the height of a school ruler. But this little measurement, which is now a mandatory part of certain doorways on these new ships, can literally be the difference between a minor problem and a full-blown catastrophe. Any thoughts on why?
It all comes down to some pretty simple physics. Like we said, these new fuels are often cryogenic, super, super cold. If there's a leak, the vapor that forms is actually heavier than the air around it, so it sinks and spreads across the floor like a fog. This 300 millimeter sill acts like a tiny little dam. It physically contains that heavy gas and stops it from flowing into safe places, like the engine room. It's such a simple but brilliant piece of engineering.
But here's the thing. LNG, that's just the start. The next wave of fuels, the truly zero-carbon ones, like ammonia and hydrogen, well, they bring a whole new set of challenges that the rulebook is now racing to address.
And this table really lays it out. You can see just how different the dangers are. With LNG, your main worry is that it's flammable and incredibly cold. Move over to ammonia, and suddenly the biggest threat is that it's extremely toxic to people. And then you get to hydrogen. I mean, look at that boiling point, minus 253 Celsius. With that, you've got extreme flammability and this thing called embrittlement, where it can actually make steel fragile. And because these are so new, the rules aren't finalized yet. They're operating under interim guidelines.
So let's take a closer look at ammonia for a second. It's a huge contender for a zero-carbon fuel, and the reason is simple. It has no carbon atoms. Great. But this creates this really fascinating problem, a kind of paradox. What's perfect for the climate is incredibly dangerous for the crew if it leaks. And you can bet the new guidelines are taking this risk super seriously. Safety isn't just one alarm, it's a layered defense. At a very low concentration, you get a local alert, and the ventilation fans kick into high gear. If it gets worse, a ship-wide alarm sounds. But if it hits a critical level, the system doesn't wait for a person to push a button. It triggers a full-on emergency shutdown, automatically cutting off the fuel and stopping the leak at its source.
Now, hydrogen is a whole other ballgame. You literally have to design the ship around its physics. As this quote says, hydrogen is the lightest element in the universe, so if it leaks, it doesn't sink, it shoots straight up and vanishes. Because of that, the safest thing to do is just put the whole fuel system out on the open deck. That way, a leak can't get trapped inside and create a huge explosion risk.
But at the end of the day, here's the most important thing to remember. You can have the most advanced ship in the world, the best safety systems money can buy, but all of it, every last bit, is useless if you don't have a well-trained crew that knows how to operate it and what to do when something goes wrong.
And that's exactly why the training standards are getting so tough. I mean, really tough. There's a basic level that all the crew has to have. But for the people in charge, the captains, the engineers, they need advanced training. And we're not just talking about sitting in a classroom. To get certified, you need at least a month of actual time at sea on one of these ships, and you have to personally take part in at least 3 refueling operations. It's all about hands-on experience.
And listen, this isn't something that's happening someday in the distant future. This is happening right now, as we speak. This timeline shows you just how fast things are moving. Critical new rules are coming into force every single year. That invisible rulebook we've been talking about, it's being written and put into action at an absolutely incredible pace.
So there you have it. The ambition for a new age of clean shipping is here. The technology is coming online, and the industry is building this incredibly detailed safety net to manage the whole thing. But with the stakes being this high, the one question we're all left with is, are we really, truly ready for the risks of this cleaner future?